this is It Makes No Difference by Michael Lefkowitz. It's rated 4-star at LMD, so it's very hard, at least for me. It doesn't require guessing, so it could be solved by logic, but it's kind of tricky, and nevertheless it's very fun, and I had some wow moments solving it. So, and we have lines which are same difference lines, which means the pair adjacent, the difference between these two digits is the same as the difference between these two, and the difference, let's say if here it was a difference of 1, another line could have a difference of 2 or even 3 or even more, like here for instance. And then we have coordinates. So this line defines coordinates reading from one end to the other. This is, so take the example x1z, xyz. The x would be the row number, y the column number, and z the value, which means for instance if we have here 2, 4, 6, this would either refer to, and this refer to some cell somewhere in the puzzle. 2, 4, 6 here would say that either there is in row 2 column 4 a 6, or row 6 column 4 a 2. So one or the other. And other lines cannot refer the same digit. So if this were, let's say this way, so these are the two possible locations. But if there were another 2, 4, 6, let's say here, 6, well, this would work, but let's see, if there were a third 2, no, 6, 4, 2, so it doesn't want, not this one, but let's see, well, here I can't because of the, but let's see, we have 4, 6, one can't have 2 here, but well, let's say could have here 2, 4, 6, a third line. It would not work, not because of the clash here, but because every cell reference from the line must be unique, so we can't use the two lines. These two lines can't refer to the same cell. So I hope this is clear. So now let's restart. I think we will start here because we have all the box one filled with all digits from 1 to 9, and these are 3 sequences with the same difference. By the way, whichever the ordering, the middle one is always the colon, and the two other also, because of the ordering, the same difference, the two extreme digits have the same parity. So if this were an odd digit, this would also be an odd digit, because if they were, let's say, odd and even, this would sum to an odd value, and this is the middle one, so the average of the two, and with something half. So if it were, let's say, 2 and 5, this can't work, because this would be 2 and a half, 2, 5, 3 and a half. So these are the same parity. These we must pay attention, because we may have repeated digits here. Indeed, there may be a difference of 0, meaning they are all the same. It could be these two digits could be the same. Let's say to 1, and then this could be 9. So it could be 1, 9, difference of 8, and difference of 8 back to 1. So we must pay attention to this. Now we'll start with these two boxes, because it looks obvious we have to start here, because they are all covered with lines, and with all the digits from 1 to 9. So we must find a sequence with the middle digit, which is not a 5. So I will write these here. See, we can start with 1, 2, 3. Then this can't be 4, 5, 6, because the 5 would go in there, or there. So it can't be 4, 5, 6, so it could be 4, 6, 8, and then 5, 7, 9. So difference of 1, 2, 2. So this is one possible combination. Then I guess we could deduce directly from the complement, 10 complement here. So 7, 8, 9, 2, 4, 6, and 5, 3, 5, 3, 1, which is the complement. We can't have 4, 7 something, it's too large. 4, 7, 10. So So this is the only one with 1, 2, 3, and would be the same this way. This is the only valid from 7, 8, 9, but maybe there are some other with 1, 3, 5. We would still need 2 something. Can't be 2, 5, 2, well, it would be 2, 6, and then 2, 6, 10. So does it work? So this is the only one. We're starting with 1, 3, 5. Then we could have 1, 4, 7. Then we need a 2. Can't be 2, 5, 8. 2, 6, 10. Doesn't work. So this can't work. And then with a difference of 4, we have 1, 5, 9. But there's a 9 in the middle, so it doesn't work. And then that's all. So there are only 2 possible combination for these 3 lines here and here. Now let's see if this one could work, because it refers to rows and columns in the same box. Says that in column 2 at the row 1 or 3 we must place a 1 or a 3, but this can't work because the 1 and the 3 are here in this case. So for this box, this is the one which works. We don't know the order, but we know the middle digits, which are 3, 4, 8. And then the others I won't tag them. There is 7, 8, 9, which would, I guess, point in there. Says that in column 8 and row 7 is a 9, or row 9 is a 7. So from this we can deduce this, and so there's either a 7 or a 9 in there, which means could have 9, 7, 5. Let's see, 9, 7, 5 here, which means that the 7, 8, 9 here is in row 7, column 8, place a 9. But here, this is the row, the column, and the value. It says that in row 9, column 7, we must place another 5, which can't work. So this is not valid for this either. So this is both use these. So the 7, 8, 9 here goes, tell us that in column 8, row 7 or 8, there is a 7 or 9, so this is 8. So row 7 column 8 place a 9 won't work because this is a little dot, a little circle. So this is row 9 column 8 place a 7, and it's a self-reference. So it tells that this digit on this line it's a 7. It's a bit like a 159 row indexer, where we have some self-references. So this is the one for this line, but there is another 789 here or somewhere, which says that in column 7, column 8, row 7, there is a 9. So the 7, 8, 9, which goes somewhere, it makes no difference where it goes, will refer to this cell. And now we have 3 and 4 here. So 3, 4 goes here. And 8. So both of these have 139, 135, which means that in column 3, in row, no, column 3, not 4, in column 3, row 1 and 5, we must place a 1 or a 5, but we have 2 such lines, so we must have 1 and 5 here, because one line will reference this cell, the other with this one. So we know that this is 1, 3, 5 here. So this line might reference itself a bit like this one, saying that in row 1, column 3, we must place a 5, or it could reference this one, row 5, column 3, no, row 5, column 3, place a 1. And it forms a pair. And the third one is 2, 4, 6, which appears 2 times again. This is the same logic. So in column 4, row 2 and 6, we may have a 2 or a 6, but there are only 2 possible locations for this combination, and we have the 2 lines here. So again, we must have these, and one will refer to this one, and the other here or here will refer to this one. So now, where do we start? Continue check this one on this one, because these are on lines. Or maybe there's some combination which can't work. Or which always, let me think, either this line refer to this, which is row 1, column 3. So it would be 1, 3, 5. Or it refers to this cell, which means that row 5, column 3, there's a 5. No, there's a 1. So add a 1, 3, 5, 1, 3, 5. I wonder, could this be 5, 3, 1? Which means this is 5, 3, 1, which means that this one refers to a 5 there. So row 5, column 3, please. No. Row 5, column 3, place a 1. No. Row 5, column 3, place a 1. And here, row 1, column 5. Row 1, column 3. That's the kind of logic which is not easy to grasp. Row 1, column 3. So either this is row 1, column 3, 5, and this is 1, 5, 1. Or this is row 5, column 3, place a 1. I can place a 5 here. Yes, row 1, column 3, place a 5. It doesn't matter the order we read it. So it could be 5. This would be 9, so this would reference to this one. Well, we can't decide, indeed. All we know is that we have a pair there and there. No, because of the logic also, we know that the difference logic, we know that these are the same parity. So this is odd. 2, 4, even, 2, 4, 6, 8. And so it could be 2. There must be difference. So 2, 4 would place a 3. Well, we can't have 2, 4, 6 because we have already 2 here, referring this one. We can't have a third one, but we could have 2. So if it were 2 here, 2, 3, 4. Two, 4, 6 would not work, so this is not 2. 2, 3, 4, or 2. No, not 2, 6. So 2, 3, 4, or 2. I will write it here and check later. Or 2, 5, 8. One way. 4, 4, 3, 2, it's done. 4, 5, 6. 6, 2 can't be 6 because this would be another 2, 4, 6. And 4, 8 must go down, and that's 8, 7, 6, or 8, 5, 2. Don't know if I should check about this. Column 3, 5 or 7. Column 3. So column 3 would be 2, 3, 4. Column 3, 2, 4. Here. So this can't be 2, 4, 6 because it would clash with this one. So maybe I should finish this first. 2, 6, 7, 9. No, maybe I don't need these reminders, these notes, because I have all the pairs here. Let's say 2, 3, 4 would place in column 3, row 2 or 4, a 2 or a 4. What card with this one? This would mean 2, 3, 4. Can't be the row 4, a 2. So this is one possible combination. 2, 3, 4 with a 2 there. Or which means this would be 1, 2, 3. No. This would mean 1, 2, 3, but 2, 3, 4, 3. 1, 2, 3 can't work. This is the only combination with a 2 in the middle range. 2, 3, 4. There would be a 3 there, and there's a 3 there, so no 3 here. And with a 2, we can only have 1, 2, 3. So this can't work. So 2, 3, 4. Oh, so this is not a 3. And so 2, 5, 8. One could still be a 2, but 2, 5, 8. Well, let's check this one. 2, 5, 8. Would say that in column 5, row 2 and 8, we place either a 2 or 8. Can't have an 8 as a value, so this is value 2 in row 8. So to place a 2 here. So 2, 5, 8 to place a 2 here. We'll note it like this. Two, 5, 8, 2, 7 is too large, and then we have 6, 5, 4, so 4, 5, 6, 4 and 6, placing 6 now. Here, placing 4 here. Column 5, row 6, placing a 4. Don't see the problem. No, 6. Row 5. No, row 6. So this is not row 7, but row 6. Row 6, 7, 8 would not work. So could it be a 7? Just wonder if it could be a 7. Six, 5, 4. Oh no, this is the case. 6, 5, 4 doesn't work because 5. Row 6 or 4 are in the same box. But this could be 6, 7, 8. Can't be 6 as the rows, so this is 8. 7. This is out. Column 7. 6, 7, 8. So 6 and 8. And row 6. Column 7. Placing an 8 here. Rows 8, column 7, placing A6 one work this way. 6, row 6, column 7, placing an 8. Why not? Again, there are quite a lot of combination or 2, 5, 8. I already done this. Six, 7, 8 would work, but 6, 5, 4. Don't remember now. 6, 5, 4 doesn't work. So 2, 5, 8 or 6, 7, 8. So this is never a 4. Is that the result? 4. 4, 3, 2. I already ruled out this. 3. can't be a 2 because of the trees. So 4, 5, 6 will place a repeated digit, so this can't be 4, 7 of course, so this is always 8. It's not easy to spot which seller reference, at least for me. There are so many options. No, must pay attention here. Which means that either this is 8 somewhere or in column 8. These can't repeat, may repeat, so they have the same validity. Whichever the case, but who knows? You can already see here. 7, 8, 9 goes in the corner in this box. So maybe I should think about this. Could it be a 2, which means 1, 2, 3? No, can't work. So this is 6, 2. So this is indeed 2, 5, 8. This would have made it simple. This is 1, 5. No, it unrolls. 1. 6 goes in here, in this box. This is all the even digits, so this is an odd digit, and this one must also be odd, not 1, 5. So that's the kind of logic I was missing first. So this must be a 3, because it must be a 3, so it could be 1, 2 odds, and to an even divided by 2 is an even. So this is even digits, so 2, 4, 6. So it could be 1, 2, 3, maybe. Column 2. Oh, I think I already ruled this column 2. Row 1, 3. But I must pay attention, so it can't be 1, 2, 3. Row 2, column 2. No, this would work. So row 1, column 2, place a 3. This could work. 2. Well, we could have 3, 2. This could be the same. One, two, three. So 2 work here. 3, 3. It says that this is the row. This is always the row here. So because there is a circle, so 1, column 2, place a 3. Yes, it works. Row 3, column something, place a 3. This doesn't have to be even, because if these were both 3, it could be any digit here. Could be a 5, 3, 5, 3. But I will check if they are different. Indeed, maybe not. Which means that 3 in row 3. Where goes the 3? Well, it's this 3. It goes in column 6. So this is indeed an even. 5, 4, 3. Row 5, column 3, place it, no. So it can't be 5, because it's a 1. Well, can't have 1, 3, 5 indeed. Could be 5, indeed. 7, 3, place a 5 there. So, I should rethink about this first. We'll build it as I go. 1, 2, 3. This one. 3, 3. 6 for this one, and then 7 and 3. These are different, so it must be a 5 there. Which means row 5, column 7, place 3. No, I can't place 2 3s here. No, column 5. No. 7, 5, 3. Column 5, row 7. This one. Place a 3. Well, it could work. Or row 9, 9 and 3, so 9, 6. Row 9, column 6, place a 3. And then there's a 3 here. It refers this one, or one which are here. Can't deduce much about it. Except that this is 2-3, 2-6. This isn't 5, so goes here. Six, seven, can't tell. Five here. Did I so column 5 to 8 can place F8, so this is a 2 in column 2 goes here. Forgot this one. Could be 888 like this, or whichever the case, these are the same, because we can't have 789 again, so we can't go up or down one way, because these are already referring these two cells, and we can't have a third line referring this one of these cells. So these are the same, so they could be can't be 1, can't be 2, can't be 3, 4, 5, 6, so it's just 7, 8 or 9. Again, it can't be 7, 9. So either they are both 7. So in column 8, placing 7, 8, 9. We have a third one, so eight in some rows 7, 8, 9. Can't refer to this one, can't refer to this one, which are these two. So it must refer to this one. So place row 8, column 8, place an 8. One way or the other. all the even digit for the row. So the rest is the odd digit. This could work. Why did I rule out the 5 there? Row 7, column 5, place a 3. Don't see the problem. Yes. This is prone to this kind of constraint, at least for me. This line now. I already said this can't be 2 because of the 1 somewhere. Because this can't be neither 3 nor 1. So it can't be 1, 2, 3. It could be 2, 3, 4, meaning in column 4, 2, 3, 4, column 3, 2 or 4, no, 2, 3, 4. column 3, 2 or 4. Well, you can't place the value over there, not here, because it's 7, 9, so 2, 3, 4 doesn't work. Or I could have a different range. There are so many options. Do I fix this? This is where I get stuck sometimes. Don't know where to look for. Two, 3, 4, 8, and 6, 2. So this must be a odd digit. 6, 2, 4, 8. So no 3, no 5. So 1, 7, 9. 1, 2. Another 1 or 3, so it can be 1. 8. Can't if again like this. I can't have 9, 7, 9, 8. So 9. This could range and repeat a 9 there, but can't. Anyhow, this is also odd. So 1, no, can be F1, 3, 5, so 7, 9. This can be 7, 8, 9. So there's no 8 here. Which means these two are the same. Can't make it a range again. 7, 8, 9. These are all already referred. So it's at where in row 7 goes to 7. It's row 7. It would be 1 or 3. Can't be 1, so it would be 3. Where in row 9 goes to 9. It would go there. In column 1 or column 3. Again, it can't be 1, so this is always a 3. Which means the 3 goes here for the row. Seven. Well, it goes to 7 in row 7. In column 3, this can't work, so this is 9, 9, 3. up or down with any difference in it. No, it means while the tree goes in row 3, which is column 6, or this is 9, 3, 6, 3, 6, 9. Whichever the case, this is a 6. So 6. It would fix this. This can't be 2, 4, 6. So this is 1, 3, 9. 2, 4, 6 goes here. 1, 5. So 3. And place a 3, column 6. So row 9, column 6, place a 3. This could work. Or row 3, column 6, place a 3. There's a 3 in there. So it means not here. Four, 6, 8, so that's all the even digits. These are odd. 3, 1. So 1, 3. So where goes the 9 in column? Well, I should have finished this one first. So place a 9 in column 3, row 9. So here. So let's fix this one. List. Do I have some other line to place? still have a line here. So what could this be? Again, can't be 1, 2, 3 because of this 3. 1, 3, 5. 1, 4, 7. Could be 1, 4, 7. Not 5, but 4. If it were 2 something, can't be 2, 3. Reason 2, 3, 4, whichever the way. If it were 3, no, 2, 5, 8 won't work. Can't have a bigger difference. Hidden pairs here, 3, 5. Maybe a simple Sudoku would solve my problem. Means there's no 8 there, no there. So it goes here. And 8. Now here, so this is a 4, 8 pair. 4, 4, 4, so this is a 4. And so now maybe 4, 6 can't work for various reasons, also because they refer to these. So it could be 1, 4, 7, 2, 4, 6. Can't have. 4, 6, 3, 4, 5. That's it. With the 4 in the middle. So it must be 1, 4, 7. Here 2, 6 and 7. Seven, 2 or 6. 2, 6 here. 2, 6, 2, 6. with this. I have to check that. I will mark it like this so I remember that if this can't be 3, this must be 3. So, what else? Where to look now? Here. 3, 4, 8. So 3. Well, indeed. So that's it. This means this is a 3. Resume to regular Sudoku. Finish the puzzle, and that's it. So sometimes it's difficult to spot, and there are some pairs and triplets here which are not always easy to spot. So that's why it took me so long. But it's really enjoyable.